Good everyone, my name is Graphics. If you look at the front of your screen, you will see a linear equation and we're told to use Gauss-Jordan method, which is also known as the Gaussian Elimination method, to analyze this given linear equation. The first thing you have to do here is for you to write this in augmented form, which we call the matrix form here, right? So it means you are separating the variable from the coefficient. So you write it in this manner. So in a matrix we have rows and column. So if you look at this, the first column should be for the x, second column should be for the y, and the third column should be for the z. So if you look at your equation very well, from equation 1, 2, and 3, the first column here, you say it is x, so take all the quotient of x, and that is 2, 3, 1. Can you see that? The equation of x is for the first equation is 2, for the second one is 3, and for the third one is what? Is 1. So we'll go to the next column, which is the column for y. So the equation of y in the first equation is 3. Equation of y in the second equation is also 2. Equation of y in the third equation, if you look at it closely, there's no y there. So you need to write out 0. Now we'll go to the third column, which is the column for z. Now for the equation 1, if you look closely, there's no z there, so you put 0. For equation 2, we have a z, but it is a negative, so you put -1. And for equation 3, we have a z, which is what? Positive of 2. That's the equation of what? Of 2. So you will now close the matrix, and close to it, you put x, y, and z. Then you draw a line, right? And the next bracket you're going to open, you put the values outside. And what are the values outside? It is 4.5, 5, and minus 0.5. So this is what we're told to do. In most cases, they don't really put x, y, and z there, but let's just move forward. Now we have 3 different rows. So in this particular kind of solving system of equation, we are working with rows. We're working with rows, and if you look this closely, this first line here, the first row, we'll call it row 1, the second row, we'll call it row 2, and the third row, we'll call it what? Row 3. So this is the row we have here. Now before we dive into business, we need to understand what it means to use Gaussian elimination method or Gauss-Jordan method. Now let's consider this matrix with element A, B, C, D, E, F, G, H, and I, right? Now your aim and target here is to make your matrix to be a upper triangular matrix. How did I mean? When you say a matrix is upper triangular matrix, it means that what? All the elements below the diagonal, right, are 0. The main diagonal are what? Are 0. Now what's the diagonal of this matrix? Is this line that you're seeing here. So you say anything below it is what? 0. And what are the things below it? We have D, G, and H. So it means that from our matrix, we need to make 3, 1, and this 0 here all to become what? 0. There must be 0. That is the game plan here. Hope you understand. So let's dive in now. Now, the thing there is this. If you look at our diagram very well, from what I was explaining, you realize that we did not touch row 1. Nothing happened to row 1. So row 1 doesn't need any change. So row 1 will always remain constant, right? So I'm going to leave a space here, and I'll now draw a matrix, and I'll write the value of row 1, which is my row 1 is what? 2, 3, 0. Then this x equals to what? 4.5. So I just rewrite this just for you to understand what we're doing, right? So I'm not touching it. So that is my row 1. So the row 1 will always remain constant. Whatever value we want to get, if we want to get row 2, we subtract it from row 1. And if we want to get row 3, we subtract also what from row 1, since row 1 remain untouched. Is that okay now? So now let's start. We need a new row 2 and row 3. We need what? A new row 2 and row 3. So what would this give rise to? So let's see from here. This is row 2. It will be row 1 minus what? Row 2. Become this way you are going to get it. Now subtract what we are looking for from row 1. We are looking for row 2. Subtract it from what? From row 1. Now the aim is to make that value here, the first element in row 2, we are looking for row 2 to be what? 0. Are we together? So we are going to do it such a way that when we subtract row 1 and row 2, we must have 0 in the first element of row 2. Right? So what are we going to do? First of all, let's write all the values of row 1. So what the value of row 1 is 230, then 4.5. And now the value of row 2 is 32 minus 1 and what? And what? And 5. Right? There's a minus in between. Is that okay now? Now, what will I multiply with 2? And also, what will I multiply with 3? Such that when I subtract both of them, they'll give me 0. To save our time, if I multiply 3 by 2, I will have 6. And if I multiply 2 by 3, I will have 6. And 6 minus 6 will give us what? 0. So it means that, since it gives me that criteria, it means that my R1 must be 3 R1. I multiply the R1 by 3 and also multiply the R2 by 2 in order to make the first element in row 2 to be what? 0. Is that okay now? So it means that every other element there, I'll multiply for row 1, I'll multiply by 3. And every element in row 2, I'll multiply by what? By 2. So at the end of the day, I'll be having from here 3 times 3 is 9 and 2 times 2 is 4. So 9 minus 4 is what? 5. 3 times 0 is 0 and minus 2 times minus 1 is plus 2. So 0 plus 2 give us 2. And 3 times 4.5 minus 2 times 5 will give us what? 3.5. So this is my new row 2. So I'll now write it here. 0, 5, 2. Then we have what? 3.5. Am I communicating? So that is the first condition that will fulfill what I'm after. Now the next thing is we want to look for row 3. So row 3 needs, remember that always subtract what you're looking for from row 1. So row 3 will give us R1 minus R3. Keep be calm. I'm still explaining. Now, I will now write all the value of R1, which is 2304.5. And I write all the value of R3, which is 102 and minus 0.5. Now, the aim is to make the first element in row 3 that we're looking for to be what? 0. Right? So you look for what you multiply to any of these elements such that when you subtract them, you are going to have what? 0. So I know my R1 here is 2. But what I multiply with 1 is 2. So because 2 times 1 is 2. And 2 minus 2 is what? Is 0. So it means that what? My R3 will not just be R3. I need to multiply R3 by 2 in order to fulfill that criteria. So meaning that every other element in R3 will be multiplied by what? By 2. So I'll place my 2 here that way. So we already have 0 here. So 3 minus 2 times 0 is 3. Because 2 times 0 is 0 and 3 minus 0 is 3. Then minus 2 times 2 is minus 4. Then 0 minus 4 will give you minus 4. 4.5 times minus 2 times 4.5 minus 2 times minus 0.5 will give you what? 5.5. Because minus 2 times minus 0.5 is 1. And 1 plus 4.5 is 5.5. So this is my new root 3. And I'm going to place it here. So I'll write 0, 3 minus 4. And we'll have what? 5.5. That is my root 3. So this is the criteria here. So this is how you put it. This is just behind the scene. Are we good? So we've already made the 0 here to be 0. So it remains one more thing to accomplish. My root 3 now, we have 3 there as the second element in root 3. So we need to make that second element in root 3 to become 0. So that means we are looking for a new root 3. So in this case here now, since remember 1 remain untouched, so you subtract from root 3 now. It will not be, the last step will just be you subtract from the what? The root 3. So whatever you are doing, subtract from what? From root 2. Is that taken? So from there I will say that, look at what I want to do. My root 3 will now give us root 2 minus root 3. Is that taken? But now let's see if it will fit the criteria. Write out the value of R2, which is 0, 5, 2, 3.5, minus all the value of R3, which is 0, 3, minus 4, and what? 5.5. Right? So when you look at that very well, you discover that we are aiming at the second element in root 3, right? Which is 3, right? So if you look at it very well, we need to make that element give us what? 0. So the question is, what will we multiply with this element that will give you 0? So if I multiply 5 by 3, I will have 15. And if I multiply 3 by 5, I will have 15. So 15 minus will give us 0. So it means that R2 must be multiplied by 3 and R2 must be multiplied by what? By 5 for you to fulfill that condition. So all elements in R2 multiplied by 3 and every other element in R3 multiplied by what? By 5. So we'll now say that we know this is already 0. Then we have 3 times 2 is 6. Minus 5 times minus 4 is plus 20. 6 plus 20 is what? 26. 3 times 3.5 minus 5 times 5.5 will give us what? Minus 17. Are we good now? So I'll now write it out to be what? 0, 0, 26, and what? Minus 17. So you see that I opened a new matrix here, right? So that's the new matrix that we have at that particular point there. So we've gotten this. So the next thing that we are going to do now is that we will now write it back in an equation manner. Remember, the first row is x, the first column is x, second column is y, and third column is z. So for the first column, the only thing we have in the first equation is 2, so we say 2x. The second column, the only value we have for y is 3, and in third column our z is 0, so I'll just have 2x plus 3y is equals to 4.5, right? So for the second equation, the second row, the first column, there's no value for x is 0, so we ignore that. The second column, there's a value for y, which is what? 5, so we have 5y, plus there's a value for z in the third column, we have what? 2z, right? Is equals to what? 3.5. And the third column, we don't have value for x for the first column. I'm talking about the third row now. Then we don't have value for y, which is also 0, but we have what? 26, which is the value for z, because on the third column, my third column is for z. So we have 26z, and that will be equals to what? Minus 17. And you're wondering why? This is just multiplication of matrix. You know, if you are very conversant with multiplication of matrix, you will know what I just did here. So if you don't really understand multiplication of matrix, you will just click on this link that is displayed at the top right corner of the screen. It will take you to where you can learn how to multiply a 3 by 3 matrix. So we'll now call this equation 1, 2, and 3. That's our new equation. So we realize that it is easier to get the value of z in equation 3 because what? It is only z that is there. So it's not an equation. The only unknown there is z, so it's not an equation. So we see from equation 3, 26z is equals to what? Minus 17. So when you make z the subject of the formula, it will now be minus 17 over 26. So you're dividing both sides by 26. Now you now put the value that you got for z into equation 2. And what's equation 2? 5y plus 2z is equals to 3.5. So when you substitute your value of z, you'll be having 5y plus 2, open bracket, minus 17 over what? 26, equals to what? 3.5. And we know 2 can go in 26, and that is 13. Are we together now? So we'll be having 5y minus 17 over 13 is equal to what? 3.5. Now you look for the LCM. The LCM there will give us what? 13. Right? So if you look for the LCM, that means since 5y doesn't have any denominator, and denominator is 1, or doesn't have any denominator, you multiply it by the 13, which is the LCM there, and that will give us 65y. But C17 has the same value as the LCM in the denominator, so you just write back 17, meaning that you just multiply it by 1. So we have what? Minus 17 equals to what? 3.5. So if I cross multiply, I will having 65y minus 17 is equal to 3.5 times what? Times 13. And 3.5 times 13 will give us what? 45.5. So it means that 65y minus 17 is equals to what? 45.5. So when you take color like terms, 65y will now be equals to what? 45.5 plus 17, because when minus 17 is going the other side, it become plus. So 65y will now be equals to 62.5, because 45.5 plus 17 will give us what? 62.5. So y will now be equals to what? 62.5 divided by what? 65. Are we together? Because we are dividing both sides by 65. Now you might be looking at in your own, you're not having 62.5 over 65. Well, how come? Now let me explain. Now I want to eradicate the decimal point there. What will I do? I'll multiply both the numerator and denominator by 10. When I do that, I'm going to be having 625 all over 650. Right? And when you do that, if you divide it, or you can start with 5. When you start with 5, 5 in 625 is 125, 5 in 650 is 130. 5 again in 125 is what? Is 25, and 5 in 130 is what? Is 26. All together. So 5 in 130 is what? We have 26. Yes. Is that taken? So let's put it that way. So we have 25 over 26. So the next one here that we have is, we've got the value of y. I can see if you divide, you can know you have 0.9615 if you want to, but we don't want to work with decimal. So we will now put the value of z and y into equation 1. And what is equation 1? 26 plus 22x plus 3y is equals to 4.5. Right? So 2x plus 3, what's the value of y? 25 over what? 26 is equals to what? 4.5. So by the time you do the needful, 2s plus 3 times 25 is 25. All over 26 is equal to 4.5. So you look for the LCM. So like I said, the LCM is 26. And since 2x doesn't have anything, multiply 2s by 26, it will give us 52x. Plus 26, since 26 in the denominator of 75, and this is the same as the LCM, that means just write back your value, which is what? 75. And this is equals to what? 4.5. So you can multiply. When you can multiply, we'll be having 52x plus 75 is equals to 4.5 times 26. Now you collect like terms. 52x will now be equals to what? 4.5 times 26 is 117. And we take 75 to the other side, become minus 75. So 117 minus 75 will give us 42. So 52x is equals to what? 42. So dividing both sides by x, it will be 42 all over 52. Dividing both sides by 52, we have what? 42 over 52. So when you do the needful, 2 can go in 42 21 times, and 2 can go in 52 26 times. So this is our value for x. So we've gotten the value for x to be 21 over 26, the value for y to be 25 over 26, and the value of z to be minus 17 over 26. So if you found this video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.